All right, now we're solving number 28. Notice now we're solving in degrees. So your answer needs to be in degrees, which means you need to have the degree symbol, not just the 0 or the 360. Make sure you have degree symbol for degrees. So what do we have here? We have two expressions being multiplied to equal 0. Looks like we got some factors here. So let's set each of these factors equal to 0. So we have tangent of theta minus 1 is equal to 0, or cosine of theta minus 1 is equal to 0. All right? So let's see what we get out of this. All right? So what do we have? We have tangent of theta minus 1 is equal to 0. This is a basic equation. We need to isolate the trig function. So let's do that process again. We're going to solve each of these as if they were the only problem up here on the board. Tangent of theta is add 1 to both sides, right? Plus 1, plus 1. And so this gives us that tangent theta. If we add the 1 across, that gives us the tangent of theta. Tangent theta is equal to 1. And we need to know how to solve tangent of theta equal 1. This is the special case. Tangent theta equal 1 is not, this is not a quadrantal angle. Tangent theta equal 1 comes from the reference angle. So that is 1, 1 square root of 2. And here's our angle theta. We want, for this angle theta, tangent is opposite over adjacent. Tangent equal to 1 is quadrantal. That's where we need to do a quadrant check and reference angle. All right, quadrant check and reference angle whenever tangent equals 1. That's the special one. Sine equals 1, cosine equals 1, that's quadrantal. Tangent, sine, or cosine equal to 0, that's quadrantal. But tangent equal 1 is the odd bird out. And so we want tangent to equal 1. So first off, quadrant check just deals with whether this is positive or negative. We want tangent to be positive. The fact that this 1 is irrelevant, the fact that it's positive. Where is tangent positive? Tangent has a positive solution in quadrants 1 and quadrant 3. All right? So we're in quadrant 1. Our quadrant check is quadrant 1 and quadrant 3. All right? And reference angle. So our reference angle, where is tangent equal to 1? Tangent is opposite over adjacent. Opposite over adjacent. Tangent of this angle gives us 1 over 1. Tangent of that angle. That angle is the reference angle. Well, what is that angle? This is a 45, 45, 90 triangle. Our theta reference is 45 degrees. So we take a 45 degree angle as the reference angle, put it in quadrant 1 and quadrant 3, and that should be pretty straightforward. So our quadrant 1 angle, well, quadrant 1, theta and theta reference are the same angle. All right? In quadrant 1, we have theta is equal to 45 degrees. Always put degrees if you have degrees. Quadrant 3, remember these are the odds, 1, 3, 5, 7. So in quadrant 3, 1, 3, 5. So theta is, I'm sorry, we're not doing radians here. We're actually doing 45 degrees. That's 180 plus an extra 45. That's 225 degrees. This is one of those weird situations where it's actually, I think, a little bit easier to do this in radians than it is degrees. But anyway, by hook or by crook, we have one set of solutions is 45 degrees. Another solution is 225 degrees, and that solves this piece. Then we need to solve for cosine minus 1 equals 0. All right, so let's isolate the trig function. Isolate the trig function. So add 1 and add 1, so this gives us cosine theta is equal to 1. That is quadrantal. Where is cosine? Where is cosine equal to 1? Well, that's at 0 degrees. It would be at 360 degrees, but we're not including 360. So the only solution we need is the 0 degree angle. And so there's one solution, 0 degrees. Here are the other two solutions, 45 degrees, and the other solution we had was 225 degrees. So those are the only solutions for that.